how to find perpendicular distance of a point from a line. So in this, here we are given a line, and this line is in 3D. It is a line in 3D space. Okay, it is not two-dimensional line. It is a three-dimensional line. So let the equation of this line be, r bar equals to a bar plus lambda b bar. Now you understand what are these all? A bar is, there would be somewhere point A. There would be somewhere point A, and position vector of that point is a bar. And what is b bar? B bar is a vector parallel to this line. So r bar equals to a bar plus lambda b bar. Now somewhere here you have a point. Somewhere here you have a point in space, and that point is, say, point P. You have a point in space, point P, whose coordinates are known to you, x1, y1, and z1. So the coordinates of point P are x1, y1, z1, or whatever, a1, b1, c1. What you have to find is, you have to find the perpendicular distance of this point from the line. See, the distance is not this. It is not this. It is the shortest distance, and the shortest distances are always the perpendicular distance. So you have to find the perpendicular distance of the point from the line. So this we have to find. Okay. We have to find the value of x1, y1, and z1. Sorry, we are given x1, y1, z1. We have to find PM. We have to find the length PM. That is the perpendicular distance. We have to find the length PM. That is, we have to find the perpendicular distance of point P from the given line. Now, how do we do it? See, for this, I shall tell you the idea. The idea would be, as I am given point A, you all know the coordinates of point A will be given to me. So suppose this x2, y2, and z2, these points are given to me. Okay, x2, y2, z2. What are x2, y2, z2? They are the coordinates of point A. The coordinates of point A are given to me. A is a given point on the line. Because I know the equation of a line, and you know the minimum requirement for getting the equation of a line is you should know one point on the line and a vector parallel to line. So here, if I'm given the equation of line, I know one point on the line, which is this point A, and I know a vector parallel to the line, which is b bar. So these two things are there with me. Now, what I will do is, I know the coordinates of the point P, I know the coordinates of one point on the line, and I know the DRS of this line. DRS of the line is known to me. How? Since I know vector b bar would be, say, a1 I cap plus b1 j cap plus c1 k cap, and this I get it from the equation of the line. You see this? So since I know the vector b bar, that is, I know the DRS of line, what I can now do is, I will find the coordinates of point M. I will find the coordinates of point M. This is x, y, z. I will find the coordinates of point M. Once I get the coordinates of point M, once I get this M, I will apply distance formula and get PM. I will apply distance formula and get PM. So I repeat, we know the point in the space P. We know one point on the line and we know a vector parallel to the line. Now from these three things, I will find out the point M, which happens to be the foot of the perpendicular. Foot of the perpendicular. It happens to be the foot of the perpendicular. I will find out the coordinates of M, which is the foot of the perpendicular from point P on the line. Foot of the perpendicular from point P on the line. Once I get coordinates of M, I can find out PM by distance formula. What is it? X minus x1 square root of x minus x1 square plus y minus y1 square plus z minus z1 square. So you don't have to worry much about this problem. This is a very important problem, but it can be solved very easily. Okay, I have explained you the method. Now I will show you the solution by taking a question. So for your reference, there is a question here from exercise 6.2. This is Maharashtra State Board textbook, question number 1. Find the length of the perpendicular from 2, -3, 1 to the line. They give us the equation of the line. Okay, so here I will draw the line. Let me draw the line, and the equation of the line is given. What is the equation of line? This is here, x plus 1 by 2 equals to y minus 3 upon 3 equals to z plus 1 upon minus 1. This is line L. Now see, so I will start my solution right away here. So I will start the solution as see, the equation of line can be rewritten as, see how I can write the equation of line. I can write x minus -1 upon 2 equals to y minus 3 upon 3 equals to z minus -1 upon -1. Now, you know, if I write the equation of the line in this form, then here I have x1, this is x2, and this is x3. This is x1, y1, and z1. x1, y1, z1. What are these? x1, y1, and z1. x1, y1, z1. They are the coordinates of a point on the line. Okay, x minus x1 upon a1 equals to y minus y1 upon b1 equals to z minus z1 upon c1. What are x1, y1, z1 here? These three numbers give the coordinate of the point on the line. They give us the coordinate of the point on the line. And what this denominator give us? The denominator give us the DRS of the line. That is, they give us a vector parallel to the line. What do they give? They give a vector parallel to the line. Okay. So I can write here. Therefore minus 1, 3, minus 1 is a point on the line, and 2i cap plus 3j cap minus 1k cap is a vector parallel to the line. See, either you can write this, or you may write 2, 3, minus 1 are, that is 2, 3, minus 1 are DRS of the line. What are they? They are DRS of the line. 2, 3, minus 1 are DRS of the line. Okay, fine. Now check this. I will take one point. I will take a vector parallel to the line, let me draw the vector parallel to the line. This is, and I write the vector as say b bar 2I cap plus 3j cap minus k cap, and I have a point which is on the line. What is the point on the line? I will take that point as -1, 3, -1. -1, 3, -1. So the point is -1, 3, -1. I take this point as A, and the vector parallel to this is B. Okay, what is the point in the space? We have to find perpendicular distance from this point. So I will take that point as P, and which is 2, -3, 1. So I have to get this distance, the perpendicular distance. Okay. So I write this point as M. So I write here referring to above figure, and I write let M, and M I write as x1, y1, z1, right? I write let M x1, y1, z1 be the foot of perpendicular from point P on the line. Okay. Now see, everybody, I have to find the coordinates of point M. If I could succeed in getting the coordinates of M, if I could find the value of x1, y1, z1, my job is done. Now see, how do I get the coordinates? The first thing I will do is I shall find out the DRS of PM. Okay, I will find out DRS of PM bar, right? So I write here DRS of PM bar is what is DRS of PM bar? You know, DRS of PM bar will be x1 minus 2, x of this minus x of this, y of this minus y of this, z of this minus z of this, right? So what is it equal to? It is x1 minus 2 is x1 minus 2, comma, y1 minus of minus 3, that is y1 plus 3, comma, z1 minus 1. These are the three DRS, okay? And please don't put them in a bracket because these three are not the coordinates. What are they? They are the DRS. So DRS of PM bar is x1 minus 2, y1 plus 3, and z1 minus 2, okay? Next. Now, I will find out now what I do is, the next step is I shall write the DRS of the line. I will write here DRS of the line R. Okay, what are the DRS of line? DRS of line R, this is also R. DRS of line R, 2, 3, minus 1. So I got the DRS of line as 2, 3, minus 1. The DRS of line we got as 2, 3, and minus 1. Now what you need to understand here is this PM bar and line are perpendicular to each other. You remember how the line was? The line was like this. And where was the point P? Point P was in space. And what is that? PM. PM is a perpendicular from point P on the line. Okay, so this was your line and this is PM. So is PM bar perpendicular to line? Definitely yes. Yes. So if PM bar and line are perpendicular, you know the sum of the product of these DRS will be equal to 0. The two vectors are perpendicular. Now when you have two lines or two vectors perpendicular, then the sum of product of corresponding numbers will be equal to 0. What does that mean? This x1 minus 2 into 2. So here I will write, since PM bar is perpendicular to line, therefore see 2 into 2 into x1 minus 2 plus 3 into y1 plus 3 plus 3 into y1 plus 3 plus minus 1 into z1 minus 1 equals to 0. Okay, when the lines are perpendicular, then the sum of the product of their DRS is 0, and when the lines are parallel, then the DRS are proportional. This thing we had done when I had taught you DRS and DCS in detail. So if you want, you can refer to that video and learn that. This had been all done in the important points to be noted. Under the heading important points, I had taken all this. Now see here, the next equation you will get is 2x1 minus 4 plus 3y1 plus 9 minus z1 plus 1 equals to 0. So you get therefore 2x1 plus 3y1 minus z1, and this gives you 9 plus 1 is 10, 10 minus 4 is 6, so plus 6 equals to 0, and this is my equation number 1. I write this as equation number 1 here. Okay. Now further, after getting this, the next step what I do is, we know the equation of this line. You know what is the equation of this line? The equation of this line was, okay, the equation of this line was x plus 1 upon 2 equals to y minus 3 upon 3 equals to z plus 1 upon minus 1. Okay. So here I will write, from the equation of line, we can write the coordinates. Of a variable point. We can write the coordinates of a variable point as follows. See, what will be the coordinates of the variable points? It will be, see, this is the equation in Cartesian form. And what do we take them all as? We take them all as equal to lambda. Now see, when x plus 1 upon 2 is equal to lambda, you will get x as 2 lambda plus 1. So it will be 2 lambda plus 1 as the x coordinate of a variable point. You know, in this equation, x, y, and z, they represent a variable point on the line. X, Y, and Z represent any point on the line. Now what would y be? Y coordinate would be, y would be 3 lambda plus 3, 3 lambda plus 3, and z will be negative lambda, minus 1 into lambda is negative lambda minus 1. And see, here what you notice is, what is this? This gives you the coordinates of a variable point on the line. It gives us the coordinates of a variable point on the line. Now the thing is, if this is the coordinates, if this is the x coordinate, y coordinate, and z coordinate of a variable point on the line, so yeah, here I made a mistake here. This is 2 lambda minus 1, not, this is 2 lambda minus 1. So 2 lambda minus 1, 3 lambda plus 3 minus lambda minus 1. What are these three? These three are the x, y, and z coordinate of a variable point on the line. So could these three be the coordinates of M? Can they represent even the coordinates of point M? Definitely yes. Definitely yes. Remember students that here you have x, y, and z coordinates of a variable point on the line. That is, these three represent all the points on the line. All the points on the line. The only thing is these three are having lambda here. That is, for lambda real value, for every real number lambda, you shall get 1 point, and that point is a point on the line. So you put lambda 1, you will get 1 point here. You put lambda 2, you will get another point. You put lambda 3, you will get another point. Like this, there are infinite real numbers which lambda can take, and you will get all the infinite points on the line. So what is important, that you got the coordinates of a variable point on the line. You got the coordinates of a variable point on the line, and this also represent the coordinates of M. Okay, so what I will do is I will write here the above coordinates will also represent point M for some specific lambda value. Okay, now see, if this represents the coordinates of point M, what does that mean? It means I have taken what we had taken point M as. We had taken point M as, if you remember, x1, y1, and z1. We had taken point M as x1, y1, and z1. So it means this can be taken as x1. This is x1, y1, and z1. So I will write, therefore x1 equals to 2 lambda minus 1, y1 equals to 3 lambda plus 3, and z1 equals to minus lambda minus 1. I write using x1, y1, and z1 in 1 we get. Okay, so here I substitute. So I get 2 into 2 lambda minus 1, 2 into 2 lambda minus 1 plus 3 into 3 lambda plus 3 plus, it is not plus, minus z1. So minus z1 is minus lambda minus 1 plus 6 equals to 0. See, this is what equation 1 becomes when I substitute. Okay. Then I have now, this becomes 4 lambda minus 2 plus 9 lambda plus 9 plus lambda plus 1 plus 6 equals to 0. Okay, so this 4 plus 9 is 13, 14 lambda, and here I get 9 minus 2 is 7, 7 plus 7 is plus 14 equals to 0. So lambda equals to minus 1. See, this is what I get. What I got lambda minus 1. So when lambda will be minus 1, when lambda is minus 1, remember, when lambda is minus 1, see, this point will become point M. As we said, what we said, this gives us the variable point on the line. For various specific values of lambda, you get various different points. Now, when lambda is minus 1, what are we going to get? We are going to get point M. So I will write here, put lambda equals to minus 1. Put lambda equals to minus 1. I write here, therefore, by putting lambda equals to minus 1, we get, see what we get. We will get point M. What we will get? We will get the coordinates of point M. Okay, so here I write, I get the coordinates of point M here. So we get here coordinates of point M. M is equal to, see, you are putting lambda is minus 1. So it will become minus 2 minus 1. See, lambda is minus 1. So minus 1 into 2 is minus 2. Minus 1 is minus 3. Then here you have lambda is minus 1. So minus 3 plus 3, you got 0. And then lambda is minus 1. So again, minus of lambda will be 1 minus 1. It will become, this will become 0 again. So you got M as minus 3, 0 and 0. What is now point M? We got minus 3, 0 and 0. And what is point P? P we had as 2 minus 3, 1. 2 minus 3, 1 was point P. So I will get PM. Therefore, PM, which is the perpendicular distance, what is it? It is 2 minus of minus 3 square, 2 minus of minus 3 the whole square, 2 minus of minus 3 the whole square, okay, plus minus 3 minus 0 square, which is minus 3 square, plus 1 minus 0 square, which is 1 square. So what is PM equal to? PM is equal to square root of, this is 5 square, 25, plus this is 9 plus 1. That is square root of 35, and this is the final answer. What we got? We got the perpendicular distance as root of 35 units. Root of 35 units. You can write the final answer as, okay, you can write the final answer as, therefore, the perpendicular distance of given point, the statement will be the perpendicular distance of given point from the given line is root 35 units. Okay, so I hope you followed. What are the things that we did? You can again check once. Now we have second question from the same exercise, and this question is similar to what we did. It is based on the same concept, but it is put differently. Now, what is being put here? Let us read it. It says, find the coordinates of the foot of the perpendicular Now you see this foot of the perpendicular. Had we done anything like this in the previous question? Definitely yes. We had found the coordinates of the foot of perpendicular. You remember it? That point M, we had found the coordinates of point M. It says find the coordinates of the foot of the perpendicular drawn from point 2 I cap minus j cap plus 3 k cap. Now what does this mean? See, there is some point in space, and instead of giving the coordinates of that point, what they are giving, instead of giving the coordinates of that point, what they are giving is the position vector of that point. They are giving us the position vector 2 I cap minus j cap plus 5 k cap. Okay, you remember that point P from where we had drawn the perpendicular on the line, and that foot of the perpendicular was M. So this is the point from where you are drawing the perpendicular to the line. And what is that line? They give us the equation of the line, and this time the equation of the line is given in vector form. Okay. Also find the length of the perpendicular. So what I notice is this question is same as the previous question, but it has been put in a different way. I have to find the length of perpendicular, but I'm given the equation not in the symmetric form, that is not in the Cartesian form, but in the vector form. Instead of giving the equation x minus x1 upon a1 equals to y minus y1 upon b1 equals to, what are they giving us? They are giving the equation in vector form, that is r bar is equal to a bar plus lambda b bar. It is okay for me. Why? Because if I have the equation this way, I know that this is the coordinates of the point on the line. This is the coordinates of the point on the line. And what is this? This is the DRS of the line. Okay, this is the DRS of the line. And instead of giving the point in the space, instead of giving the coordinates of the point, see, they could have said, find the distance from the point 2 minus 1, 5. Find the perpendicular distance from the point 2 minus 1, 5 to the line. Okay, so we had to find this. In that case, we would have had to find this. But they are not giving us the coordinates of the point. They are giving us the position vector of the point, which means the same thing. Okay, so what we would do first, we would draw a sketch which will help us go ahead. So we will draw a sketch, a figure we will draw here. So see, I have a line here. I have a line, and I will write, I have a line here. The equation of the line is, I write here, it is r bar equals to 11 I cap minus 2 j cap minus 8 k cap plus lambda times 10 I cap minus 4 j cap minus 11 k cap. Okay, this is the line. Now, if I have this line, so I understand that one point on the line will be, one point on the line somewhere is say A, and it is 11 comma minus 2 comma minus 8. Okay, and I have this, so I understand DRS of the line, and then I have a point P here from where I have to get the length of the perpendicular. So see this point P, and I have to get, okay, I have to get this perpendicular. But before that, I have to get the foot of the perpendicular. So I write this as M. I have to find the coordinates of the foot of perpendicular, right? What is this point P? They are not giving us the coordinate, but they have given us the position vector. You understand what does it mean? It simply means that somewhere we would have the origin, right? Somewhere we have an origin, and from origin you are given this. You are given this vector. From somewhere you have origin, so you are given this vector. And what is this vector? This vector is 2 I cap minus j cap plus 5 k cap. Now you need to understand, if this vector is 2 I cap minus j cap plus 5 k cap, it simply means that the coordinates of point P are 2 minus 1 comma 5. Okay, so please don't go for showing this vector. This is simply not required. Okay, this is not required. Please, this is not required. You would not show it. Okay, if you show this, nothing wrong in that, but then it doesn't signify. So here we have what we have to get. We have to get the foot of the perpendicular. So I will write here, let M be the foot of the perpendicular. Here I first of all write, my answer starts from here. I write referring to the diagram. I write here referring to the diagram, referring to above figure, and then what I will write, let M x1 y1 z1, let M x1 y1 z1 be the foot of perpendicular from point P to the line, to the given line, okay, to the given line, okay. So now I will find out the DRS of PM. Okay, I will find out the DRS of PM. So I write here, DRS of PM bar are given as, so it will be x1 minus 2, comma, y1 minus of minus 1, that is y1 plus 1, comma, z1 minus 5. Okay, so we got the DRS of PM bar. Then what are the DRS of line C? DRS of this line, you have this line L, right? So DRS of the line you will get from this vector, okay? So I write here, DRS of the line are, what are the DRS of the line? 10, minus 4, minus 11. Now see, I have the DRS of the line and the DRS of PM bar. Now PM bar and DRS, and PM bar and the line are perpendicular. Now see, you all need to understand, student, that this, whatever is happening now, this is very unique. You know, this point M is perpendicular to the line, and when this happens, this M is unique. This will happen only at one single point. The perpendicular from this point. See, this point is fixed. Now, if I take anywhere else, that would not be a perpendicular. Even the slightest of movement will not give me the perpendicular. The perpendicular will happen only at that M. And this thing is very, very, very unique. It is specific. And that is what is solving our problem. You know, this is one very specific point. So what I will say is PM bar, the next I write is, see, I got the DRS of PM bar and I got the DRS of line. I will write, since PM bar is perpendicular to the line, therefore, you know what will happen. 10 into x1 minus 2, 10 into x1 minus 2 plus minus 4 into y1 plus 1 plus minus 11 into z1 minus 5 equals to 0. This whole thing will be equal to 0. So you will get 10x1 minus 20 minus 4y1 minus 4 minus 11z1 plus 55 minus 11z1 plus 55 equals to 0. So you have therefore 10x1 minus 4y1 minus 11z1, okay, minus 11z1, this will become minus 24 plus 55. So if it was minus 25, it would have given me 30. So what I get 31. So plus 31 equals to 0. And this is equation number 1. This is equation number 1 you have. Okay. Now what does this equation signify? You all need to understand what is so special about this equation. See, in this equation you have 10x1 minus 4y1 minus 11z1 plus 31 equals to 0. Now I took point M here. Now as such, as of now we do not know what are x1, y1, z1, but we only know one thing, that a point on this line, we know only one thing as of now, that a point on this line having 3 coordinates, x, y, and z coordinates, if it satisfies this, then it would be M. Okay, so for M, we got a specific relation. Okay, now how do we get that? How do we go ahead? Let us see this. From the given equation of line, I will write from the equation of line, we can write the coordinates of a variable point on the line as follows. We can write the coordinates of a variable point on the line as follows. See how we will write. What is the given equation of the line? The given equation of the line is r bar equals to, you have the position vector of the point plus lambda, then you have the DRS of the line, right? So what is that? It is 11 I cap minus 2 j cap plus 8, sorry, it is not plus, it is minus 8 k cap, and then here you have 10 I cap minus 4 j cap minus 11 k cap. Okay, and what is r bar, students? R bar is xi cap. R bar is here where you have r bar, you can replace that r bar by, this r bar by xi cap plus yj cap plus zk cap, where x, y, z represents what? A variable point on the line. So now you can write here the variable point as x equals to, see, x equals to, this x equals to, it is xi cap. So from here, what will be the coefficient of I cap? 10 lambda plus 11. It is 10 lambda plus 11. This is x. Okay, and what will be yj cap? What will be the coefficient of j cap? You can check here. See, it will be minus 4 lambda. You see this? This lambda will multiply minus 4 j cap. So minus 4 lambda minus 2, minus 4 lambda minus 2. And what will be z equals to? Z coordinate will be equal to, minus 11 lambda minus 8. Okay, minus 11 lambda minus 8 k cap. So k cap is common, you will get this. So you got the x, y, and z values, and remember this x, y, and z was nothing but the coordinates of a variable point on the line. Okay, so I will write therefore 10 lambda plus 11, 10 lambda plus 11, 10 lambda plus 11 comma minus 4 lambda minus 2 comma minus 11 lambda minus 8 represents a variable point on the line Okay. Now students, the question here is, can this variable point represent m? Can this variable point represent m? Can this be x1, y1 and z1? Yes. Yes, this can also be x1, y1, z1 because m is also one of the point on the line. M is nothing but a point on the line. But remember, if this variable point represents the coordinates of point M, then they must also satisfy this equation which we got for M. So what will be the next step? The next step is I will write the above coordinates can also represent coordinates of point M. Okay, I will write that is x1 equals to 10 lambda plus 11, y1 equals to minus 4 lambda minus 2, and z1 equals to minus 7 lambda minus 8. So I write here using x1, y1, z1 in 1. So what do you get? You get here see, what was that equation? It was 10 times x1. So you have 10 times 10 lambda plus 11. Then you have minus 4 y1. So minus 4 times, what is y1? Y1 is minus 4 lambda minus 2. Okay. Minus 11 times z1. So minus 11 times z1. What is z1? Z1 is minus 11 minus 8, minus 11 lambda minus 8, okay, plus 31 equals to 0, so 100 lambda plus 110 plus 16 lambda plus 8 plus 121 lambda plus 88 plus 31 equals to 0. So here we got, see, this is lambda and lambda terms. So this becomes 237 lambda. This is 237 lambda. Okay, plus how much is this? See, this is 118 plus 88, 118 plus 88 plus 31. So how much is this? 8. This is 7, 1, so 2 and 8, 10, again 13, 3, 1, 237 equals to 0. Okay. So what is lambda equals to? Lambda equals to minus 1. Lambda is coming minus 1 because minus 237 upon 237. Okay, so I will see here. I got lambda. So lambda is negative 1. Try understanding. When lambda is negative 1, then whatever x, y, z you get, it will belong to point M. It will belong to point M. So I will get x1. I write here using lambda, we get what we get. See, the coordinates will become x1 will become, see, minus. So you are putting lambda as -1. So this is -10 plus 11. That is 1. So x1 is equal to 1, right? And y1. See, this will become +4. +4 minus 2 is -2. +4 minus 2 is 2. Okay. Lambda is -1. So this is +4. +4 minus 2. Here. You get lambda is -1. So this is +11. +11 minus 8 is 3. And what is Z1? Z1 is 3. So you got the M. See, what was M? What was M? M was x1 over Z1. You got it as 1, 2, 3. You got the foot of perpendicular. This is foot of perpendicular. Foot of perpendicular from point P to the line. Okay, now what? I want the length. I want the length of perpendicular. So here I write length of perpendicular. Length of perpendicular equals to PM equals to the formula. What is the formula? See here. What was P? 2 minus 1, 5. Okay. So this is 1, 2, 3. That is what we just found. So 2 minus 1 square. So 2 minus 1 square plus 2 minus 1 square plus -1 minus 2 square minus 1 minus 2 minus 1 minus 2 square plus 5 minus 3 square. 5 minus 3 square. Let us check. So -1 minus 2 square, 5 minus 3 square. Correct. So how much is this? So you have, this is equal to square root of 1 square is 1 plus 9. Okay. Minus 3 square is 9. And then you have 2 square plus 4. So how much is this? This is equal to square root of 14. We got the length of perpendicular, and that is your final answer. I hope you all followed this. Please see this again, watch this again, and learn it well.